Alright, now this problem deals with the actual second fundamental theorem of calculus. Because if we have h of x is the integral from 0 to x of this function, then h prime of x, the derivative of h, is just f of x. So, let's see, h prime of 3 is just going to be f of 3. Well, f of 3 is, somewhere around -5. Is that greater than 0? No. So that one's out. H prime of x has a relative maximum at x equals 2. So now h prime of x is f of x. So does f of x, as we follow it, have a relative maximum at 2? No. F of x has a relative maximum back here. But h of x, which would be the integral would actually have a relative maximum here. So if it was h of x, then it would be this. This one would be okay. But since it's h prime, we're talking about the original function now. We're talking about f of x. And it doesn't have a relative maximum at 2. It has a 0 at 2. So this one's out. H of x, now that's the integral function, so we're counting area, has a relative maximum at x equals 5. So somewhere around here, does the integral have a relative maximum there? So let's think about what the integral is doing. We're adding positive area all through here, then we start taking away area. So h has a relative max there. Now we're taking away area, taking away area, taking away area, adding area. So right here it has a relative min. H does. Now we're adding area, adding area, adding area. After this point at 5, we keep adding more area. So this is not a relative maximum for h, not for the integral. For the original function, yeah. So this one is wrong. So none of these are actually true. If these two were switched, then both of them would be true. Because h has a relative maximum at 2. The integral function has a relative maximum at 2. And h prime has a relative maximum at around 5. Looks around 5. So anyway, this one is just trying to make sure that you understand the difference between the integral function and the original function when you're using the second fundamental theorem of calculus.